Hi, chapter 11, risk and returns. So last chapter we saw the very important lessons from capital market history, which is the risk return trade-off. Now this chapter show how to calculate the return and the risk, and what kind of risk that we can actually avoid, and what kind of risk that we cannot avoid. So first of all, how to compute the expected returns. We are going to do scenario analysis here. So when we compute the expected return with different scenarios, such as the good economy, bad economy, normal economy, the expected returns are based on the probability of the possible outcomes. So expected return is sum of the product of the probability and the return on each scenario. So this is the scenario, stock A and B. So we have possibility that the economy is recession 25%, 50% neutral, and boom economy 25%. And these are the schedule of the return and stock A and B. What is the expected returns? So we're going to use Excel spreadsheet here, stock A and B. If you look at this, okay, stock A and B, okay. So the first thing we have to do is, by the way, this spreadsheet is posted on Moodle, so you can download and practice, and you can also use this spreadsheet in quiz and exam. Okay. Probability times returns. This one also probability times return in neutral, and probability of the boom times the return on boom. And then sum of these three will be the expected return. So expected return on stock A is 11.25%. Okay? Now for stock B, again the same way, probability times return on recession, and just copy everything. Basically show the neutral and the boom, and then sum of the threes will be expected return 12.5% for B. So this is how to compute expected returns. Okay. Now how to compute the risk. Risk is measured by the variance and standard deviation. And as we saw in chapter 10, the variance is the sum of the square deviations divided by n-1 in historical observations, historical data, and standard deviation is square root of the variance. It's very similar, but because we have different scenario and we have probability, instead of just dividing by the n-1, we basically just multiply each probability and then add them up. So first you find the square deviation from the expected return from each return in each scenario times probability, and some of them will be the variance, and the standard deviation is simply the square root of the variance. So let's use Excel again to compute that. For A, now the return in recession minus expected return, and also return neutral minus expected returns, and return boom minus expected return will be the deviation from the mean, right? And then you take the square root from this one, image. Okay, and times probability. The probability is here, right? So probability times squared deviation. Again, probability times squared deviation. And probability times squared deviations. And sum of these three will be the variance. Okay. And then the square root of the variance will be the standard deviation. Standard deviation is 19.8% for A. But B, the same way again. You take the deviation from the expected return from to each returns. So let's fix it. D17 and copy. And copy everything, right? I'm sorry. And then you take the square from the deviation and the copy. And times probability. Again, copy. Okay. The variance will be sum of these three. And square root of this variance will be the standard deviation, 14.36%. So that's how to compute the standard deviation. Okay, so you easily get the expected return and the standard deviation. Now, let's talk about the portfolio. So previous examples is just one asset, A and B. But most people actually hold a portfolio, which is a collection of the assets, collection of the number of assets. Why we form the portfolio? We don't want to put all egg one basket. That's why we want to form a portfolio. We want to diversify the certain level of the risk away. So this portfolio is also treated as one asset actually. And as we know, obviously the assets risk return impact basically how stock affect the risk and return of the portfolio. And in fact the risk return trade-off that we learned in chapter 10 for the portfolio is actually measured by the portfolio expected return and standard deviation, same as individual asset. So we can treat the portfolio as one asset. So how to find the portfolio expected return? If we have expected return in each asset, then the expected return of the portfolio is simply the weighted average of the portfolio. I mean, each expected returns. What is the weight? Weight is the percent of the portfolio invested in each asset, which means that the dollar invested in certain assets, here asset J, divided by total investment. So how to find the portfolio weight? Again, let's go to the next spreadsheet here. Oh, I already calculated, so let's just delete again and then see if how to find the weight in each investment from stock A and D. So there's 5 stock A, B, C, D, E, and 15,000 invested in A, 8,600 B, 11,000 C, 9,800 D, 5,800 E. So total investment $50,200. Now how to find the weight? Weight is simple. The invest in A divided by what? Total investment. So 29.88% A. For B, again 17.13%. For C, 21.91%. For D, 19.52%, and for E, 11.55%, and the sum of these weights should be 1, right? Yeah, total investment. So that's how to find the portfolio weight. Now how to find the portfolio returns? So let's go back to the spreadsheet again. This is the return schedule. We have 3 scenarios: recession, neutral, boom, and 5 stocks, right? So what we have to do is the first step, step 1, find the portfolio returns for each scenario. That's the first step. Okay? How to find it? We calculate the weighted average. Weighted average is simply the weight times return A, weight times return A, return B, I'm sorry, and weight times weight so AC times return C, weight D times return D, weight E times return E. So that's the portfolio returns. Negative 2.9% for recession. So this is sum of weight times returns in each. So in fact, there is called sum product, the function, and you can actually just set this is one series and the other series is this one. Then you can find the same one actually. This is same as this. Same thing, sum product of weight and return in boom. So this is the schedule of the portfolio. This is the portfolio returns in each economic scenario, each economic state. Now, what we can do is that we can ignore just these 5. We just use this one to compute the expected return and the standard deviation as we did in the previous problem. Because we can treat this portfolio as one asset. So, now next spreadsheet is you just take the returns for each economic conditions, and to find the expected returns, first of all we have to find the probability times each returns, right? And then sum of these 3 will be the expected return 10%. Now what about the variance? Variance will be, again, the return minus expected returns, the deviation, and let's fix and copy so that we can compute the deviation from each return and the expected return here, and then take the square and times probability. And sum of these three will be the variance, and the square root of the variance will be standard deviation, 7.57%. So for this portfolio, the expected return is 10% and standard deviation is 7.57%. So I want you to practice these problems using the spreadsheet posted on Moodle, and you can use this template in quiz and exam to save the time. Now the third spreadsheet is about the benefit of the portfolio. So now I compute each expected return and the standard deviation for 5 stocks, and then so I already computed that, and then find the weighted average of the standard deviation and compare with portfolio standard deviation. So this is compared with the weighted average of standard deviation versus portfolio standard deviation, okay? And find that the weighted average is greater, portfolio standard deviation is less. The meaning is, now we basically find that the return is kind of weighted average, right? So we don't lose any returns. However, the standard deviation decrease. So it means that with 5 assets, just simply by combining the 5 assets, we still keep the returns but reduce the risk. That's the benefit of the portfolio. So if you form a portfolio, you may diversify the risk away. So that's a lesson here. Again, portfolio standard deviation is not a weighted average of standard deviation of the component securities risk. So there is benefit of portfolio. Okay. That's the end of the first clip.